And here we are with our chapter 2, and we're doing day 3 here. Notes, technically if you're looking at the book, it's chapter 2, section 6. Either way, it's our third day on chapter 2, and we are now talking about writing two-column proofs when it comes to geometry specifically. So there will be algebra involved, of course, but it's going to also use some of our new geometry theorems. So first thing we're going to do is prove geometric theorems by using deductive reasoning. So our vocabulary is theorems and two-column proofs, which of course we've heard of a little bit. A theorem, here's our definition, is any statement that you can prove. And of course we have talked about proofs. So a theorem can be proven. Once you have proven a theorem, it's kind of now in your toolbox, and you can use it as a reason later on. So again, once we have known how to do what we're learning today in our theorems, we can use that forever after this. Before you start writing a proof, you should plan out your logic, okay? So it is a good idea to kind of know where you're going before you start going, right? It's kind of like having a map or having your GPS working before you leave. So sometimes you will be given a plan for more challenging proofs. So sometimes one of the columns might be filled in, like we saw on our previous assignment. This plan will detail the major steps of the proof, and you get to fill in kind of those reasons why it makes sense. So our first theorem here is going to be the linear pair theorem. So there's a linear pair theorem stating that if two angles form a linear pair, then they are supplementary. So again, linear pair meaning on a line. And so of course if they're on a line is 180 degrees, and therefore it's supplementary. All right, the next theorem that you can pull out of your toolbox is going to be the congruent supplements theorem. So if two angles are supplementary to the same angle or to two congruent angles, then the two angles are congruent. So again, they're saying, hey, this thing plus an angle I know equals 180. And let's see, if two angles are supplementary. And then they're saying, hey, this thing plus another angle equals 180. Well, then those two things must be the same. And so that's kind of what they're asking here, or saying here in that theorem. The next one is the right angle congruence theorem. Turns out all right angles are congruent because they're the same. Okay, so if you ever see a right angle or a 90-degree angle, it turns out it will match every other 90-degree angle, kind of like any other angle measure. If you see a 60-degree angle, it better be very close to a 60-degree angle of another one. But just in general, all right angles are congruent, so we can jump to the fact that they are equal. The next one is congruent complements theorem. So just as congruent supplements theorem, congruent complements theorem says, hey, you've got two angles, they add to 90, another two angles add to 90. Those pieces are going to end up somehow being linked, and in this case, congruent. All right, so we have two examples here that we're going to go through, and you can see here on this one, this is actually very much what the book will look like, because they, of course, don't want you to write in the book. So technically we've got a space here we're filling out, a space here, here, and here that we're going to fill in. So we're going to fill in the blanks to complete a two-column proof of one case of the congruent supplements theorem. So we are proving this theorem. So after today and today's assignment, or tomorrow's assignment, we will be able to just pull this from our toolbox. So we're going to prove that it works so that it's one of our tools. All right, so from what we've looked at here, angle 1 and angle 2 are supplementary. So even though this may or may not make a linear pair, 1 and 2 are in fact going to add to 180. They also tell us that 2 and 3 are also supplementary. So we've got this piece here, and then this same angle here are going to also make 180 degrees. So on that note, they didn't actually say 180 degrees, they only said supplementary. So because of the definition of something being supplementary, we are able to say that 1 and 2 adds to 180, and 2 and 3 adds to 180. So Because I can't necessarily fit this all in here, I am going to do a little dot dot dot. Basically, I'm going to say that angle 1 and angle 2 are blah 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 blah, because I'm actually going to be using this entire phrase and putting it in there. Now, you should not actually do that when it comes to your assignment, because if you don't write it down, there's a lot of tendency for you to actually forget that it was even part of what was given. So, anyway, this entire phrase here should actually be this entire thing here. I just couldn't fit it. All right. Then in number 3, they're saying that some substitution is going to happen. Okay, so based on what we see here, it looks like I'm going to take the measure of 180 and actually take the fact that this is equal to 180 and plug it in to this 180. So again, I'm going to take this statement that said it's also 180 and plug it in. This could also be known as the transitive property, and so this happens a lot with transitive and substitution, is that sometimes they can interchange. So either way, both of them are equal to 180, so let's go ahead and say they're equal to each other. So the measure of angle 1 plus the measure of angle 2 is going to equal to the measure of angle 2 plus the measure of angle 3. All right. After that, they're going to get into the fact that the measure of angle 2 is equal to the measure of angle 2. And of course, the reason that something is equal to itself is by that reflexive property, okay? And then now that we know that the measure of angle 2 is equal to the measure of angle 2, we can actually go ahead and subtract out the angle 2's, and notice that we're left with angle 1 and 3 equal. So again, we're subtracting out the angles that are number 2, and we'll have 1 equals 3. So there is one thing that the book tends to get too specific on, and that is this last part here. There is a difference, right, between equals and congruence, okay? When I teach this, however, I pretty much say they're the same thing, and I don't care if you actually write congruent or equal too much. I mean, clearly I'll do it correctly each time, but if you accidentally put equals instead of congruent, it's all good. Because remember that equals is for numbers, and congruent is for shapes or objects. And so, basically what they're saying here in number 5 is that the measure of angle 1 equals the measure of angle 2. Super. So your next statement would be that the measure of angle 1 is congruent, because that's actually what we're trying to prove, to the measure of angle 3. And so basically you might feel like you have just done a redundant statement, right? Measure of angle 1 and 3 are equal, and so of course angle 1 and 3 are congruent. In fact, when you say this part, you don't even need the m, because now we're not talking about the number. We're just talking about the object itself being congruent to another object. So, the book does this all the time. They call it the definition of congruence. All right, and again, that is because the definition of congruence is that their measures are equal. All right, so again, equal and congruent are going to be interchangeable, and so if you don't write the definition of congruence ever in your proofs, that is perfectly acceptable as well. I personally would have stopped this proof right here and been done, because we all know that equal and congruent are the same thing. All right. The next one here, we are going to now write a 2-column proof for the supplementary supplementary congruence. Congruent supplements theorem, yes. So, on the next slide is actually our proof, but let's just double check what they're giving us. Number 1 and 2 are supplementary, so 1 and 2 are 180 degrees, and then they're also telling us that 1 and 3 are equal. Okay, so we need to prove then that 3 and 2 are supplementary. So again, the computer is not reading these symbols, and so it's giving me little boxes. So I've filled in all the boxes with the angles and then the congruent symbol. All right, so thinking of the reasons that go with this, angle 1 and 2 are supplementary, and 1 and 3 are congruent is your given. Pretty much always given. Okay. The next piece is going to be that the measure of angle 1 plus the measure of angle 2 is 180 degrees. And that's actually by the definition of something being supplementary. If you knew that it added to 180, that was its definition, because supplementary is two angles that add to 180 degrees. Perfect. The next thing here is saying that the measure of angle 1 equals the measure of angle 3, and then this again is the fancy one from the book. And that's going to be the definition of congruence. And again, not going to be asked for, but if you want to be super specific, again, it's just because they have an equal sign here instead of a congruent sign, like at the beginning. All right. Then the next piece says that we're going to take the measure of angle 3 and add it to the measure of angle 2. And so the only difference between the step 2 and 4 was the fact that these two were given as equal, and so we've supplemented it. Substituted. So again, instead of writing 1, we wrote 3, and so therefore we have substituted it in. Now they're saying, once you said that they could add to be 180, you can now say that those two angles are supplementary, and we're going to go by the definition of supplementary. Again, a lot of these feels like you're saying, well, because duh, okay? But at the same time, we do actually need a reason why, because someone jumping into our geometry class, for instance, is not going to necessarily know the definition of substitution. And so if you say it, now they know to look that up and realize, oh, that meant that they were supposed to add, and I can see why you would say that. All right. So those are our examples, and so we are going to do some proofs. Again, you may be asked to prove some of the theorems in your assignment that we have talked about today, and that's going to be only today, and then after that you won't have to prove them. So, for instance, after today's assignment, you will not need to prove that something is a congruent supplement. So you can just say, oh, I'm going to jump to the fact that they're equal and not have to write that proof because it's one of my theorems.